Introduction. Transportation is the movement of people and objects from one point of origin to another, the destination. The most common movement is the home to work cycle, where people need to get to and from work. This movement can take various forms, and the study of these forms is called transportation engineering. Transportation is also considered to be a means of communication. The most common means of travel are pedestrian transport, walking, road transport, cars, buses, taxis, bicycles, etc., rail transport, trains, air transport, and water transport. Oh, I see, they mention air transport. Origin to destination, that's just describing what happened here. Then you have your transportation communication. So now we have, can you think of any other means of transport? How do you get to work, the shopping center, classes, cinemas? So for the purpose of this course, we will concentrate on the general aspect of road construction in South Africa: earthworks, pavement design, pavement construction, and drainage. Road construction follows basically the same process as any other construction project and involves investigations, route location, road design, setting out work boundaries, construction and opening of road to the public. Now you have site investigations. Before any project is undertaken, there must be a need for that particular service. The need will be defined by any one of a number of role players: national government, local authority, the public, or any other parties that may have some interest in the project. Once the need has been identified, someone, the client, takes ownership of the project and in most cases makes funds available for the design and construction works. Before the final location of the road is fixed, several interim studies are undertaken: a desktop study, a preliminary investigation, and a detailed investigation. So basically, with this site investigation, where they give an explanation of your once the need has been identified, someone, the client. So the client can be a group of people, organization, or community, or fundraisers, or people with stock fails, and then they want to build like a road or something like that, for ease of movement, then they basically hire a consulting engineer who actually does the design, and the consulting engineer will decide who the construction engineers or the construction technicians or the construction company, they will decide who the construction company actually is that they want to work with, because usually they have people that they prefer working with because they know those people get the job done. That's one of the reasons why the client always hire the consulting engineer, and then the consulting engineer hires the construction engineers. In some cases, the clients, they want to be difficult, and then they want to actually hire the construction and the consulting engineers. But if you hire a company, consulting engineering company, that there's a good reputation, chances it's very minor that they might give you that type of power to decide who you want to hire for the construction, because they also have a reputation to protect. And then before the final location of the road is fixed, several interim studies are undertaken. Okay, that one we did already. Now we'll go over the desktop study, the preliminary investigation, and a detailed investigation. So desktop studies, this is the first step during which the beginning and end points of the road are fixed an example, the origin A to the destination B. Origin A to destination B. Origin A to destination B. Then they say once these points have been fixed, a broad region will be determined in which all possible routes between A and B will be explored. So basically the origin from point A to B will be established, and then once these points have been fixed, a broad region will be determined in which all possible routes between A and B will be exposed. So a broader region, which is this region A, will be determined in which different routes will be established. So the routes, let's just see, possible routes between A and B will be established. So the possible routes is the corridors. So this is done by establishing several broad bands. Okay, so the broad bands is basically 1, 2. So in this broad band we have 2 corridors. In that broad band we have 1 corridor, and then we have an open field. So that's all that they are explaining there, which means this is done by establishing several broad bands of 8 to 16 kilometers wide in the case of major rural areas. So from here to here might be like 8 kilometers, from here to there might be like 16 kilometers. Those are the broad bands. Okay, in which, so in the case of major rural roads, in which to concentrate, so they will focus on those areas there. Those are the areas that they will be focusing on. To refine the search, basically refine is just to improve the search even further. Several corridors of 1 to 1.5 kilometers wide will be investigated. So these corridors of 1.5 to 1 to 1.5 meters will be investigated, and they will establish those corridors, the corridor D, E, and F, as you can see in that case. So that's it for desktop. Let me just see if it's continuing. Yeah, the best and most suitable corridor will be established, after which the alignment of the road will be determined. So the best and the most suitable corridor will be established. It's basically that line that you see there, the route G. That's the best corridor for the road to be established. Or basically this is the best corridor. The corridor E is the best for the road, or for the route to be established, the main route. That's actually what I mean with the best and the most suitable corridor will be established, after which the alignment of the road will be determined. The alignment of the road is that black line that you can see here. That's the alignment of the road, aligning or just connecting point region A with region B, because that's determining the possible route between A and B. And then they say this takes place in the office as a desktop study before the actual design of the road takes place. So all that happens before the road actually gets constructed. Okay, so preliminary study. Am I pronouncing it the right way? The preliminary study is a large-scale investigation of the alignments established in the desktop study. At this stage, all the physical information that may affect the location of the road is collected. This includes the position and inward levels of streams, the shape of the ground, and the position of the trees, culverts, bridges, existing roads, etc. So if you engineer, you will know what inward levels is, and natural ground levels, formation levels. You will know all of those things. That's basically just doing your surveying on paper. Like I might go over it in the future, not near future. It depends, if I hit my targets, if YouTube start paying me for my information, then I might do those type of detailed explanations of everything, Like when I see I get like millions and millions of rands, that's only when I start exposing those type of information. Because you gotta know, man, you gotta know. All things have a price, man. Expensive information has expensive prices on it. expensive price tags on it. We can't expose stuff like that unless I'm getting paid. Like that's exclusive information. That's really confidential and private. So we won't be exposing stuff like that here. We'll just give you the theory, and calculations is something else. Like I might show you a sketch, bro, of what I used to do back time when I was in university, but I'm not going to explain it. Like I can show you a sketch now of those things. So that's basically just doing your grid lines and your contours. That's how we used to do it. This is doing your cut and fill. So there you have your cover level, formation level, cut fill area, volume, accumulative values, and then when they accumulate the volume, and then you have your stake values. That's another cut and fill. Usually we will cut that and then we will fill those areas, most likely just to be economically, and then you get a straight road at the end of the day. This is just doing natural earth levels. That's your top of your pipe. So your invert levels, your depth, your distances, cover levels, and that's your main pipe, sewage pipe. So we used to do that, but I'm not gonna cover that. If I have to cover that, people should start paying me. And then there's some other stuff also that we used to do. I remember this was my second drawings. My first one I got like 5%. This was my third one actually. My second one I got like 14%. And then my lecturer actually gave me a third revision, so she allowed me to redo it the third time, and then I got 98%. That's basically just that. But we won't cover that there, or we won't cover it here. That's in the future. Like usually they will give us like the natural ground levels, because at the end of the day that's what the land surveys do. They come with their GPSs and then they take a couple of heights, and locations, directions, and then they basically give it to the civil engineer, and then the civil engineer from there on they actually do the grids, the contours, the calculation of the material to be excavated, and all those things. And at the end of the day it links up with your trucks, your dump trucks. You will know how many trucks you should, or how many loads you will have. At the end of the day that's going to lead to your calculation of your costs for your diesel and your tire usage and your maintenance on your vehicles. So it's a whole process, but it all actually links, It all comes to primary studies. So detailed investigation. The survey serves the dual purpose of definitely fixing the center line of the road and preparing final design plans for construction purposes. Detailing design will include horizontal and vertical alignments. So horizontal, vertical curves. There's also calculations that I didn't show, but yeah, discussed later in this unit. The accumulation of the design will be the accumulation of the design will be realized by the pegging of the center line and determining levels on site before construction begins. So basically they have these pegs. That's what they call pegging. So they have pegs that they actually set out, and that determines, the stake values of the road. So the intervals at which they break the road down. I think usually we used to use 10 meter stake values. Some people use 20 meter stake values. and that's just to help you determine the level of the site before construction begins. That's so it's helping you to determine the levels of the site. With funding being drastically reduced from central government towards road construction and maintenance, private initiatives have emerged. For example, some farmers in KwaZulu-Natal are funding repairs to road works in order to improve the road network from their farms to nearby towns. So it's not always like the government, they tax you, but at the end of the day, they stay reckless with spending that money because they don't know how to manage it, I'm assuming. But it's always up to the local investors, the people that's actually, making money in that area, like your farmers, your local stores, they should actually form like a boardroom, and basically come together with the government and then ask them, listen here, isn't there a way that you can maybe fund like 50%, 30%, 100, 90%, 80% of the project? Because we actually see that our infrastructure is being demolished, and it's basically, being destroyed now, and it's wearing out because it's been used for the last 10 years or whatever. Like at least every 10 years they should have like proper maintenance on their structure, especially infrastructures such as stadiums, sport facilities for the youth, like the roads, um, like relax places, what do you call it, resorts, stuff like that, parks, actually parks, not resorts, like parks, stuff like that, man. Like it's up to the community and the government to actually, participate in that, and then to actually resolve those problems together, because at the end of the day, we know that reckless spending in the government is a huge thing, man, because they don't know how to manage the tax money. Or even if they do manage it the right way, maybe provincially, in a higher, if they do distribute it right, like locally, there's always mismanagement because people steal money, stuff like that. They don't use it for the right infrastructure and things. So after funding has been secured, a competent person or persons, usually a consulting engineer practice, is appointed to carry out the planning and design of the road. Before the design of the road can begin, a thorough investigation of the prevailing conditions needs to be made. This investigation is carried out by means of aerial photographs and a site investigation, during which all the factors that have a bearing on the road's final location are considered. So basically, all that they are stating here is that before road construction begins, the prevailing conditions, the current conditions needs to be investigation on the prevailing conditions needs to be made. So they need to investigate the conditions currently, if there's existing roads, and if there's a lot of damage to it, or if it's just minor, and then they have to decide how they're gonna go from there on. And then they say all these investigations is carried out by means of aerial photos, which is usually, nowadays they use drones. Back in the days they used to use helicopters. And site investigations. When the road is built in an existing residential area, other services like drainage pipes, electrical cables, water pipes, and telephone cables will be present in the area. The position and depth of these services must be established before excavation begins. And that's important because you don't want to damage infrastructure that's already there by excavating too deep or stuff like that, like you don't want to do damage already to existing services. And now you basically have route location. Once the route has been determined on the drawings, a field surveyor must be, this is where the field surveyor is actually going out, must be carried out. A field survey must be carried out to fix the center lines and determine ground levels. Okay, now this is just like, we can also do it. Like, this is normal engineers, civil engineers can also do it, but I thought they were gonna talk about the actual ground levels, getting the ground levels. A field survey, or like your first 2 points, like you're setting out points, that's what they usually come set out, the surveys. A field unless you're a civil engineer and you can do it yourself also. So let's just carry on. A field survey must be carried out to fix the center line and determine ground levels along the proposed route. Final levels must be accurate, as these form the basis of the next phase that actually form the basis for the next phase. The actual, okay, there's a okay, so they say for the next phase, what do you call it, a puncture, the actual design of the road, before we get on with the next phase, you know. And then they just say the actual design of the road, which is the next phase, the road design. When a road is designed, several factors must be taken into account. The design can be compared to a recipe for baking a cake. If any of the ingredients are incorrect or missing, the cake will flop. The road design must cater for all the elements necessary to make the travel safe. These include, okay, so this basically includes cross-sectional elements, for example the width, crossfall, road reserve, lanes, etc. Now this is just explaining all these things. Your verge, road reserve, road prism, road bed, median, roadway, carriageway, lane, side drains, shoulder, break point. That's just explaining that basically outer shoulder, which is A, and then your inner soldier, which is B. Okay, so basically that's the cross-sectional elements. That's basically just explaining this. Then you have your design speed. That's basically determining, you know, that's horizontal. That's basically horizontal and vertical alignments. That's where you do design speeds. Side distance, sloping, braking distance, vertical alignment, horizontal alignment. But design speed and these two usually go together. Intersections and pavement thickness. So that's basically for that. But it's basically just doing your vertical, horizontal alignment. So these elements of design all relates to the road's geometry. These elements of design all relates to the road's geometry. In other words, what the complete road will eventually look like. So after this we'll do, but this is on another video, the setting out, construction and opening of the road to the public, and then road terminology. We'll do that on the next video. And most likely classifications of roads, and then the earthworks. Like I can actually do classifications of roads now and then just catch up with it later on, just in case, you know, I run out of space, because I actually don't have like an external hard drive, so I can't save this. Like if I can get a 2 terabyte or 4 terabyte, that will be enough. So let's quickly do that. So you have your roads in South Africa classified according to their functions and traffic characteristics. The classification system is as follows. Class 1, national primary roads. For example, the N1, N2, N3 have limited access. In other words, you can only get onto a freeway at specific areas, and these can be quite far apart. When next you drive on a it should probably when next time you drive on a freeway like the N1. See how easy it is to gain access to it from your home. And then you have case 2, arterials are high capacity roads that supplement the movement of traffic around the city. They give direct access to the freeways, but not to the residential or industrial plots. And then you have district distributors carry high volumes of traffic and are the links between higher and lower classes of roads. And then you have local distributors are roads that link neighborhoods and are often used as bus routes. And then you have class 5 access roads are further subdivided into cul-de-sacs, I don't know what that is, loops, etc., and form the network of residential developments. They give direct access to people's homes. The classification is called a hierarchy and graded according to a numbering system, number 1 being the highest grading and number 5 the lowest. The geometric configuration is related to this classification. The higher the classification, the more stringent its safety factors, the more stringent its safety factors. And basically this is all that they were explaining there. You have your local distributors, access roads, your district distributors, your aerials, and your primary roads, and then we'll cover the rest in the next video, starting from setting out. And that's basically it for this video. So I'll see you guys in the next one. Don't forget to follow.